Today we're going to jump to chapter 8. We finished up 12. We did a selected topic. Today we're going to do 8. We're going to spend 2, maybe 3 days on 8. We'll do another selected topic, and then you're going to have your first test on chapters 12 and 8. Okay, so code listings were coming in fast and furious this morning, but hopefully everybody got them in. Those zeros start to add up pretty quick, so stay away from them. It's worse when you had 121 because not only was it code listings, but it was assignments, it was quizzes, and the folks with the zeros, they just kept adding up, and it was not a good thing. All right, so we're coming back and we're going to talk more about classes. And one of the sections actually you should have had in 121. My 121 students were told to cover it, but it should have looked familiar when you were doing the code listings. All right, so we're going to start with static class members. And the reason I'm using my book is because we're going to do a bunch of stuff with the code listings, looking at those today. And part of the reason you type them in is to have you prepared for class, but also now you have blocks of code available. You have working blocks of code available. You have blocks that you can manipulate if you need to. But we're going to start talking about static class members. And there's that word static. It's been seen so many times up to this point, but never really used for anything. Well, we're going to take a look at the two different types of static members that we can use. Okay, when we talk about members, we're talking about first fields. Okay, and the second thing we talk about are the methods within it. Going back, if I gave you a UML chart, look something like this, all of a sudden we start talking about fields. That's radius. We only have one field here. And methods. That's all of these guys below. So these are members of a class, the fields and the methods. Okay, so what does static do? Well, this is kind of neat, kind of clever. I have in front of me a class called countable. Okay, so one of the things we need to do is be able to go back and knock off some rust about classes. So if I was to throw this in front of you, the first thing you would say, oh, that's a blank. What was this called?
UML chart.
Yeah, it is a UML chart. Okay, this is a UML chart for the class circle. Now, up at the top is the name of the class. It's circle. The first thing beside it right here or underneath it is any fields that I have. Okay, in this case, I have radius. When we go back and talk about the class rectangle, one you use quite a bit in 121, what were the fields in that class?
Private.
No. What were the two variables that we used throughout?
Length and width.
Radius.
Yeah, length and width. Why didn't we use area?
Because it'd be better to.
Yes, I got that. The reason is it creates something called stale data. So if I had a variable called length, and if I had the variable, here it is. If I had length, width, and the length was 6 and the width was 4, and say I had another variable called area, and I calculated the area to be 24, and then because I had to calculate it to get it, and then I went and said, oh, let's change length to 10. I measured wrong, and all of a sudden I said, get area, because I wanted to get well, this value's wrong. It wasn't recalculated. It was stale and old. So that's why we never included a variable like area. We always calculated it so that it would stay fresh depending on what the new length and width were. So when you're looking at this guy right here, we only need one. The only information I need to figure out everything about a circle is the radius. Okay. My radius has a data type of double. Somebody already mentioned, what does that minus represent?
But it's
Private,
private.
Good. What do the pluses represent?
Public.
public,
Public. What are these first two guys right here? They have the same name as the class. They are
Instructors.
constructors. And when I have more than one, what's the O word that I use to reference a constructor or to reference one of these constructors? The constructors are
Overloaded.
objects,
overloaded. Very good. They are overloaded. Okay. I have my set function, or excuse me, method. Functions is C++. My set method was my mutator. My get was my accessor. This has a value coming in. It's a void method. This doesn't have any values coming in, but it's returning a double. Some other methods that I have, get circumference, get area, both returning data types of double. Down here at the bottom, toString. If you had me, you were supposed to have been able to do a toString when we were in chapter 6 working with classes. Okay, a toString, and I said, oh, you have to jump ahead to section 8.4 to get that information. Well, today we're going to hit 8.4. All right, so before we move along any farther in our class, and right now countable is a class, but down here's a constructor, right? It's the default constructor, but I'm adding a new field in here called instance count. And instead of what I used to have, I now include the word static. And when I say static, what that means is any object that uses this class and adds something to this variable, it sticks. It sticks. An example would be, what if I have I'm in charge of a company and I own 4 McDonald's, okay? And I need to know how many hamburgers to order. So what if I had a class with total hamburgers, and then each company could create their own object, but they could also add to the total. And every time each one added the total, I'd have a final total. It's not a separate variable like length and width that are unique to each object. Okay, this is one that's available to all objects and maintains its value. So in this case, we have, whenever I instantiated an object of countable, what was in the constructor was I added one to that static variable. So when this program gets run over and over and over, which is code listing 8.2, 8.2, I instantiate this first object. Okay, when I do this, it goes over, hits the constructor. The constructor adds one to my static variable. I instantiate a second object. I instantiate a third object. So each time I do this, it's adding one to my static variable. When I get ready and display the output, I use the method that is provided. I just pick one of my objects. It doesn't matter which one. I use the get instant count. It goes in there and returns how many, that number, and it says 3. We will continue to do static stuff in other classes as well. But that is our first static member. It's a static field. Questions? I'm going to throw this one at you. Static method. This is number 2. Okay. When a class has a static method, it's not necessarily for any instance of the class. Boy, that's a big name. I don't even have to have an object to call it. So if I look down here, public static double kilometers to miles, I don't have to have an object name in front of it. Have we seen this before? Were we able to use methods that are stored in a class without instantiating an object?
No.
The plane, boss, the plane. Give me an example of a static method that I didn't need an object for. P O double U. PAL, right? PAL. That's from the class math.pal, but I never had to use PAL on an object. I just referred to it with the class name and was able to go and use that method. So all of those methods in the math class are static. I can just go and use them without attaching an object's name. Give me another class that's like that. You would have learned about it in chapter 9.
J option pane.
No,
That's not one from chapter 9, but that is
Yeah.
one that uses static, isn't it?
right. But I'm thinking of the character methods. Remember we had the character class and we'd go character dot to uppercase kind of deal. Okay, so when you typed in 8.3, you had this static method so that when you then typed in 8.4 to go with it, I got ready and I called the class name, which was metric, and I used that static method. Just like I would call the class math and use .pal, or I would call the class character and use to upper. Those are all static methods. Questions? Good. Okay, section 8.2. Section 8.2 talks about being able to pass an object as an argument. So if I come up here in the main, I see I'm creating, I'm instantiating an object called box. Okay, getting back to all of our class lingo. Some of you took 121 last semester. Some of you may have taken it a year and a half ago or even longer than that. So I'm trying to get some of the lingo back for you. But we're going to instantiate an object box from the rectangle class. We're familiar with the rectangle class, right? Length and width is probably going on and bring it all out. And one of the things that I can do is this fellow right here. I can call a method called change rectangle, and I can pass that object in. So right here, box is passing in the object I created. It's going down and it's going to land in my parameter list. I'm just going to call it R. And just like I would have had an int or a double or any other data type, this R that's coming in has to have a data type in front of it. In this case, it's the class we created called rectangle. Now you notice inside of here, I set length to 0 and set width to 0. And when I look at the output, the values are in fact changed. Okay, this goes back to what I'm passing in is an actual address. I'm passing in an address. So when I do that, I can make the changes in here and the changes will stick so that when I go back up, even though I printed it out originally and 12 and 5 came out, now 0 and 0 are coming out. So just like anything else that I would like to put as an argument, line 20, this box is an argument, and it goes down and lands in my parameter list. I need a data type to match up with it. And in this case, unlike our primitive data types, changes that I make will change because I'm passing in a reference here. Similar to like we did with strings. So far, so good? Yeah, buddy? Okay. Now, just as much as I can have an object as an argument going into my parameter list, I can also have methods where my return type is an object. So I'm going to create an object called bank account, which means when I go down to this method get account, I'm going to be creating another object and I'm going to be returning it. The object I create better be of type bank account. When I go to that method, here it is, get account. Its return type is bank account. So inside of here, I get some information. Okay. I return new bank account with whatever that balance is. So this line 44 is actually instantiating the object as it's being returned. So I have a bank account and it's going to return it here. So again, just like everything else we've done up to this point with methods in our classes or just methods, I can pass as arguments a data type, I can return it. We did it with the primitives. We did it with string. We did it with arrays, that we were able to pass anything in and or have anything as a return type. Questions? We are moving right along. Okay, not everybody knows this one, but in section 8.4, there's something called toString. Now, if I got ready and I instantiated an object, and let's say it's R1, okay, from my rectangle class, I instantiated an object, rectangle R1 equals new rectangle. If I said display system.out.print R1, what would I get? Let me make a note of that over here. If I said rectangle, okay, and I said R1 equals new rectangle 4 and 5. So I instantiated an object called R1, and I gave length the value of 4, width the value of 5. If I said system.out.println R1, what would I get?
Do you get the address?
Well, yeah, we're going to get some kind of something that's set up, and it's set up way up here above. It's going to be set up in something called a superclass that we're going to get into really quick, okay? But it's something that's already set up. Now, we can override that setup, okay? We're going to override it. Now, what do? Well, that toString is written in this upper higher level class. That's the default. So when I try to print R1, it goes and finds it up there. But if I rewrite a toString, I can now print out. So if I looked here right now, if I said system.out.println XYZ company, it's just going to dump a memory address and something else. But if I include a toString in my class, that now gets overridden, and this is what would print out. Okay, so what is a toString? It's a method that has a return type of a string, so I have to return a string. It has no parameter list, nothing's coming in, but I can create something nice that'll print out by using the fields that might be in this class. I could use the methods that are in this class, but I could put together something really nice to print. So when I get ready and say system.out.print the object, it'll refer back and take that toString. Okay, with me? How are we doing for time? We're still pretty good. Okay, I'm going to do one more section. That's section 8.5. All right, and something called an equals method. If I tried to compare two objects, well, I write it when we have it here, but I'll get my notes in a minute. If I said I'd like to know if the object company 1 is equal to company 2, what would actually be compared when I do this?
References.
Go ahead.
References.
Yeah, it would tell me, are they the same address? And they might, right? They might be the same address, but chances are we never have them point to the same address. Okay, so if I want to know if these two are equal, there's a couple of ways that I can take care of this. Okay? We're going to take a look at one, and the idea is to write an equals method. Okay, you can't tell if they're equals by going like this. It'll only tell the addresses. So what do I need to do? I'm going to write a method, a Boolean method called equals. What's going to be passed in is an object, R2. Does anybody want to say D2? R2, okay? Inside of here, all right, I need to write something with a return type of Boolean where I say if, let's see, with rectangle, if length equals R2's dot length and width equals R2 dot width, return true, else return false. Should I say that again? So right now, I have my current objects, length and width. I'm going to say if length equals R2 dot length and width equals R2 dot width, then return false, otherwise return true. That's going to be in my method. Then when I get ready and I go to my program, I can do something along the lines of if R1, that's the calling object, that's the left or the length and width that are over here, dot equals R2. That's the one that's being passed in. So this would be a method called dot equals that we want to write so that I can compare two objects. When I'm in here, I have to do that sort of what we call deep comparing, where I compare the length to R2's length, the width to R2's width. So if I was to ask you to write this, I'm now saying, oh, we want to also add an equals with the parameter of a circle coming in, and the return type would be Boolean. If I give you this UML chart, can you create the class and then write a demo program to test the class? Create a default object, create an object that has a single parameter, and do a couple, test all these, but have a nice toString for if I get ready and want to print out circ1, it'll say circ1's radius is its circumference is blah, 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 and its area is blah, blah, blah kind of deal. Questions? Doo-doo. Doo-doo-doo. Okay, I'm going to create breakout rooms. If you forget what's on here, give me a holler. But I want you to write a class and a demo for Circle. When you're done, we're done.